Well, hello. Welcome to my channel. This is my first video on here, and this video I am posting to address comments in videos regarding rockets, and in particular, rockets in space, trying to address comments talking about how rockets supposedly can't work in a vacuum. So I'm putting together this little simulation here. This program is called Algodo. It is a physics simulator in which you can create all sorts of different geometries, and you can play with them in different ways. You can simulate how they fall in gravity, how things collide with each other, all these sorts of things. So what I have set up here is I just took a block of material and I carved out a couple elements of a typical cold gas rocket thruster. It's cold gas because we're not going to be dealing with ignition here. It's just working with the internal compression of all of the gas elements inside the container here. And then we're going to see what happens when they flow out the back. Now, the common claim is that rockets need to push off something. They'll refer to maybe cars pushing off a road or boats or things like that, but really all these are just two different reactions in different ways. Cars are pushing off a road, so then the car moves forward. Boats are causing water to accelerate backwards. That's actually what's going on there, not so much pushing off. Same thing with airplanes and lift. They are changing the velocities of things to cause a opposite reaction. Rockets are a little bit different though. They bring their own propellant. They bring their mass. And that's sometimes one criticism. One thing that we first have to establish with some of these people is just the question of, does gas have mass? It's kind of a hurdle sometimes, but you'll notice inside all of these I have these round little circles. These represent individual gas molecules, and I can actually click on these and look at the material, change things, density, mass, all sorts of little things. And now, sure, a single gas particle doesn't have very much mass, but it still has mass, and it all adds up. This is why we get chamber pressure. With that, we now look at how these are going to work in here. So the question is how is this getting any sort of forward momentum if it's not pushing off anything? Like I said, the common claim is that it's pushing off the ground. There is no ground here. Or it's pushing off of air. Here, I have air resistance. We're not bothering with air resistance since this is meant to be space, so there's no air to push off of. Sometimes they say, well, in a vacuum chamber, when you've done these tests, it's pushing off the wall of a vacuum chamber. Again, no wall anywhere in this. But if that's the case, then, and I'm just using the laws of physics, just mass bouncing off of mass, how is this going to be moving at all? Well, a couple things is that one is that we have to understand kind of how gas particles work. From what we understand, gas particles are undergoing elastic collisions. That is, they're all bouncing around very, very quickly. They're bouncing off of each other, and they're bouncing off the walls of their container. That's why we have air pressure. 15 pounds per square inch, that means these little molecules are actually pushing with 15 pounds on every square inch of surface we have in normal ambient atmosphere. Now, but you also notice that you don't really feel those 15 pounds pushing on you. That's because our bodies are already pushing out, but also because there's a net momentum of zero, which is going to get me into why I have this pattern here. You'll notice each one of these molecules, there's a down and an up, a right and a left. All of these are going to cancel out momentum. So these two, even though each one has momentum, that is, remember, velocity times this mass, they are going to cancel out each other. So this one and this one cancel out to zero. This and this cancel out to zero. So really, there is zero net momentum in this. Right now, this block is at a standstill. And so really, we shouldn't have any movement as we start. Secondly, you'll notice all these are very well organized. That's just to show you that these have zero net momentum. But as these get going, you'll notice that they do start to get chaotic, that they are bouncing in all different ways. And why don't we take a moment, see what that looks like. Now I have this I'm just going to set this to the slowest setting right now. You'll notice it does look like it's nice and organized, but it's not perfectly centered. So you'll notice as we start this simulation, it does bounce around. We do get particles moving, but you'll notice that pretty quickly it gets chaotic. Not just in positions, but also in velocities. We're going to have variations in how fast these are moving. Some of them are moving fast, some of them are moving slow. But that's just the nature of how we can get these collisions at angles, and as well as the angles that they hit these walls and these curved walls here. Okay, so what is this all leading to? What this is leading to is that these are going to be colliding this side just as much as they're colliding this side. They'll be colliding with the top just as often as they're colliding on the bottom. It doesn't so much matter if one of these is hitting this one and then traveling all the way up straight to the top to hit this one. We don't have to have a single one ping-ponging back and forth. It can still transfer those forces through the web of all of these molecules inside. But we can take a look at how that's going to look. So let's go ahead and play. I am going to turn on a grid so that you can see how much this is moving, and you can see we do get a little bit of leakage. This plug here isn't perfectly in here, so they do get in there sometimes. But let's take a look at how much this moves over time. In fact, I can even click this and visualize the momentum. And you'll notice the momentum is moving around a bit, left and right, but sometimes up, sometimes it goes down. But it's really not moving around all that much, is it? That's because it's also pushing down on this one, which means it's, as much as it's pushing it to go forward, it's also pushing it to go down. So now, this is where it gets to the point. Remember, they claim that this has to be pushing off of something. Again, no wall, no vacuum chamber, no atmosphere. So then, how is it, once I take these two plugs, I delete them, what's going to start happening? Means all of these molecules, as much as they're pushing down, some will still push down here, some will push down here, but all the ones that have a momentum going backwards, they're going to keep going backwards. They're not going to hit this side and impart a backwards movement. They're just going to leave. So that means we have more molecules pushing forward than we have molecules pushing this back. So let's see what happens when we hit play. Look at that. You'll notice that this is starting to move up a little bit. You'll notice that we have all of these moving out the back. It's still going at first, as you can see, but that's because I have it at the slow speed. How about we speed it up a little bit? As you can see, as all these are flying back, this is moving up. How can that be? In fact, let's go ahead and we'll take that selection, we'll just follow it. And we'll see what happens with the speed. Look at that, it's still moving forward. In fact, wow, this momentum indicator is just going up and up and up. And you'll notice these are just keep flowing out the back. You see, all the ones that are carrying momentum to push backwards, they're getting expelled, which means all we have left in the container are the ones pushing forward. They're going to keep getting forward until more and more of them fly out the back. Another thing to notice with this one is sometimes we're going to have different particles moving in different ways. Let's take a look at how some of these particles fly out. Let's try to find one that is going to be flying at the walls at a particular angle. So here we have one. Let's take a look at this one. You'll notice it still has some upward speed, but this one is approaching this wall here. Notice how the velocity is pushing this way. Let's see what happens when it hits. Some of that velocity changed in another direction. This arrow got smaller. That's because it imparted some more of its energy forward, which is part of the reason why we have an engine bell. And as we continue following this, we'll see it just keeps going forward faster and faster. Now there will be a point where the acceleration of this slows down as it runs out of fuel. That is, there are no particles pushing forward, but since it's in space and there are no other forces pushing it back, that means although the acceleration is slowing down, the velocity is going to continue to stay constant. It's basically a derivative of the acceleration. And with that, you can see this is just going to keep on going. Like I said, it's eventually going to come to a constant velocity, but it's going to take some time as this pressure lowers and lowers and lowers. They're going to come out less and less frequently because it just takes more chances for it to come out, and that's basically why it sometimes takes a time for this to come out. Now, obviously, this isn't covering any other elements of rockets. We're not getting into different kinds of temperature things or cooling or other kind of plumbing, those sorts of issues. That could be for a different video, or watch someone like Scott Manley or Everyday Astronaut to get much more better information on that. You do see a little bit of rotation here, but that's just because this is a very, very, very small amount of particles. Some are maybe just hitting this a little bit more right now, but then you're going to have some that are going to cancel that out eventually, hit this, and it'll go the other way. It's just part of the nature of this one. And I do have a second model that has many, many more of these particles, and that one actually stays straighter, but they're smaller and harder to see what's going on. But with that, as you can see, and even if we zoom out, you'll see that we've gone quite a bit for ways since the origin here. You'll see all of these gas particles are still expanding out now that they've been expelled, and this one just continues moving forward. So there you go. Funny, no walls, no ground, nothing to push off. I just used the fuel inside to get this moving forward. Seems like that claim is pretty well busted now. Okay, thank you for watching.